afternoon, everyone. Welcome to class. So this is the 15th session for this program. We're making progress as usual, but I've actually looked at the remaining classes we need to have, and I think we'll need to move at a faster pace because we are still in the second phase or the second part of the program, which is the data analysis part. Remember, I told you that we have the Python programming part, then the data analysis part, then we have the machine learning. Ideally by now, this week, we should actually have entered machine learning. So although it's still possible, as we can round off with visualization today and then start with machine learning tomorrow. The reason I say this is because the whole thing curriculum should end by the 12th week, and we are in the 8th week now. So we basically have 4 more weeks to go. We have week 9, week 10, week 11, and week 12. And we roughly have about 8 more topics, all right, or 8 more sessions that are all under machine learning. So I think we are going to be moving at a faster pace, and we're also going to be extending. We might be overshooting the classes at some point, all right, so as to cover some of these topics well enough, right? So for today, we're going to do data visualization, look at it, and just give you an idea on how you can visualize your data. So this is not an extensive class on data visualization. We are actually not going to go in depth into visualization, right? Because this is a data science program, so the goal or the aim is not going to be on visualizing. Rather, we're going to spend more time on the machine learning aspect, right? But regardless, we are still going to look at visualization and how we can use it. So moving forward, we are supposed to have a correction class. For those of us that attended the correction class yesterday, you should know that we've treated all the corrections up till week 7. So we're supposed to do week 7 correction after the deadline, right? So which is today's class. But I'm just going to pause on that, and if we have time tomorrow, we're going to do that. So I'm trying to maximize the time we have. As I said in the correction class yesterday, most of the assignments that I'm giving, they're basically things that we did in class. So it's basically easy for you to correct yourself. All right. So by going through what we've done already. All right. So the other things I mentioned in the correction class, like the things that are not really pertaining to the questions, are those things that you might have needed to hear. You probably needed to hear. So you would take note of them. All right, so but for today's class, we'll not be doing any correction. We'll just go straight to what we have for today's class. All right. I want to also commend everyone for sticking so far. It has not been easy. All right. I can see that there's a drop in the assignment submission. All right. So we usually have over 200 submissions, but now we're having barely 200. We're having 100 and something, which actually still follows a pattern for the previous cohort. So as you progress in anything you're doing, some persons would actually drop off for some reasons and a lot of other factors, right? So it's something I noticed, and I just wanted to let you know. And something else that I also wanted to mention is, please, I want to encourage all of us to put ourselves out there on social media, especially LinkedIn. I usually see some of you posting on LinkedIn, which is very commendable, but I don't see as much persons that do that. So I said I was going to say and talk about it in the class. So please, if you're on LinkedIn, try as much as you can to just drop 1 or 2 things, whatever it is you learn in a week. You can just find a way to arrange the whole the points that you've picked, and then put it out there. All right, it doesn't have to be perfect. You don't have to have figured out everything before you start like making yourself visible, right? So it's part of the growth, it's part of the journey to help you, and it also give you that visibility. So please, I want to commend us or to encourage us to put out there, especially on LinkedIn, and make posts that are relating to data science. All right. So I think that is just it. Before I proceed with the class, now I always like make sure I have everything up to date. Gideon and Nigeria, please, is there anything that I need to know, right? Because recently I have actually been very, very, very like busy. I've been on stable jobs. I'm having some going on, so I've not been stable like past 2 years. I've cut with every single thing and all of that. So I just want to my very job so far. I've been covering a lot of ground, and also the class rep and assistant. So while I make sure that I come up here every Saturday and Sunday to take our classes. So if there's anything I'm missing, please class rep and assistants, please, the mic is yours. Just let me know. If there's none, let me just proceed with the class.
Good evening, sir.
Yeah, good evening, Nigeria.
Thank you so much, sir, for the sacrifice and efforts and everything. I really do appreciate. Nothing serious, just a few things to mention. There was a discussion that was going on the group, but you already replied to that, and you said you're going to reply. You said you're going to respond to that. Then concerning the assignments, there were a little bit of issues that people had, and they did not really understand. And the course rep was able to organize, organize a class to explain some of the parts and things for people to understand. And then lastly, is just the grade for some people's assignments. They don't really understand why they have some certain grades. So I'm already in contact with you and the assistant tutor too. So he has already replied to a good number of them, and he's still on some. So for now, that is it. And thank you so much, sir, for the revision class yesterday on the assignment. So that is all that I have for now on my side. Also, the course rep has a little bit of hitchback on his network at the moment, but he's working on it, so he'll be joining us soon.
Okay, thank you very much for the updates. I really appreciate that. So regarding the assignments, I believe most of us have been getting responses from the assistant tutor, right? As much as we can, we reply everyone, and you'll get to know why you got what you got. Okay, so so the recording for yesterday corrections class is also available on the materials group. So you can, if you miss the class, you can go to the group and get access to the video recording and then catch up with what we've done so far. I would also want to apologize for every other inconvenience that you've been having so far. I would have to be honest with you that it's actually not easy having persons in a particular class and ensuring that everything is going 100%. Like, you won't understand until you are in that position. So we are trying our best to keep up with every single issue that we are having. All right, and all hands are on deck to make sure that as many as we can, we would resolve those issues. So I want to apologize once again and thank you for your patience so far, because a lot of you have been actually very patient with issues that you've had for a while now and all of that. So, but in that patience, ensure that you are still trying to catch up, or you are still getting the main thing from this program, which is understanding understanding what we are communicating. I believe in that aspect, in the aspect of communicating knowledge and explaining stuff. I think we're actually doing very well when it comes to that. So if some other things might not be going very well for you, exactly very well for you, at least you should be getting value in that regard, right? So hopefully we're going to try to resolve as many as we can. All right, and those that I said I was going to reply, yeah, I'm still I'm still on it. I took note of every single one, and I'm going to to reply to them. Yeah, thank you very much. So let's go straight to. I actually was supposed to make this material available for this class. It skipped my mind. So this is week 8. Week 8. You can see that I have to even change this because in the last course, this was week 7 material. So you can see that we're actually behind in our schedule already. So but let's go ahead with what we have for today. So today we are looking at data visualization, and as we have been doing so far, we'll be introducing a new library called Matplotlib. All right, so all right, so I'm gonna. So we're going to be introducing a new library in today's class, which is called Matplotlib. All right, so Matplotlib is another library that we are going to be using in Python for visualizing our data. So we have all right. All right, so we have it here, data visualization with Matplotlib. So now, Matplotlib is the library, as we understand what the library is. We've looked at several libraries now. We've looked at NumPy. We've looked at pandas. Let me just come to libraries. Look at so far. We've looked at NumPy. We've looked at pandas. We've looked at, and we are now going to look at Matplotlib. Anyways, I think I'll just include that and Seaborn. So Seaborn is a visualization library as well, but it's used alongside Matplotlib, right? So I'll just include this here because I might chip it in as we proceed with the class. So today we're going to be looking at Matplotlib. Let me just say, today we're going to be looking at Matplotlib library, or Seaborn rather. So Matplotlib is basically used for plotting. Matplotlib. Right, so if you separate, this is a kind of compound word that came together. So this math here came from MATLAB. So MATLAB is like a software that is used for performing, like doing statistics and visualization and a lot of other stuff. While plot is your normal plot. You know what plotting is, to plot a graph. While lib here mean library, right? So this is where we got the Matplotlib from. So Matplotlib is a library that you use to plot graphs, right, in the MATLAB style. So MATLAB is a software that's a statistical software, right, that you can use to actually plot graphs and charts and all of those things. So we're going to see how we would use Matplotlib. I don't need to start introducing how to use libraries again. You already know how to use a library. So before I even proceed with this, let me just go through the material, and let me see if I can quickly share this material. So those that wish to follow can actually follow. So just give me some seconds. See if I can share the material. Okay, so if you check the group now, you see the material there. I've shared it for those that wish to follow alongside this class. All right, so the material is already available. All right, so let's go back to the material. So we have the outline. So we're going to look at what data visualization. I think we've looked at this in the previous class. We're going to look at common data visualization techniques, but I'm going to recap them actually. We're going to look at Matplotlib's core concepts. All right. We're going to look at using Matplotlib for data visualization, and then how to plot various charts with Matplotlib. So the outline for Matplotlib is pretty straightforward. We don't really have a lot to look at as compared to when we compare it with NumPy and when we compare it with NumPy and Pandas, we don't really have a lot to look at either, right? So, but we're going to try to, as much as we can, to wrap up with all of this today. So let's look at what data visualization is. So I've explained this in the previous slide, just skimmed through it, but I'm going to go over it again. So data visualization is the art of representing information in a graphical format. All right. So what you are doing here is to represent information in a graphical format. Why? To make it easier to understand, analyze, and communicate trends, patterns, and relationships within your data. So it's obvious that when you look at numbers on your Excel sheet or your Pandas data frame, you probably would not understand what is going on unless you take your time to go in depth into the details to understand the trend that is happening within your data. But when you convert or you represent those numbers in a graph, you realize that, oh, this thing is actually easier to understand, that, okay, this is the relationship this particular variable is having with this variable, or this is the trend in this particular variable, right? So you're going to understand how visualization helps making understanding your data very easy. Okay, so what you do in visualization is basically transforming raw numbers into visual elements. If you have actually taken a visualization course standalone before, you would actually go in depth into it, and they will talk to you about visual elements, right? The different parts of visual of the graph and the content and the things that comprise a chart or a graph, and a lot of other things, right? Right. So we are not going to go in depth and dissect all of those things, but I just need you to understand some basics about visualization. So what you are doing in visualization is transforming raw numbers. All right, you have your raw numbers, you transform them into visual elements, right? Like charts, graphs, maps, allowing human perception to grasp insights that might be difficult to glean from tables or spreadsheets alone. So, as I said before, that the phrase there's a phrase that we usually use, right? A picture says 1,000 words, all right, something like that, is actually true, because once you have a number or a data represented in a graph, like, it brings you to a whole new dimension of understanding. Like, it actually allows you to see meaning that you are not previously seeing. So let's move on. So what are the benefits of data visualization? I think I've explained it already, so I'm just going to quickly go through it. The first one here is enhanced understanding. Visualizations simplify complex data. This is obvious because you basically convert the raw data to visuals, which simplifies those complex data, making it easier to identify patterns, trends, and relationships. So visualization also improves communication. Okay, so let's say you want to communicate a finding to your boss. But as a data analyst, your boss told you to go and like just perform some analysis on a data that was given to you. So once you're done with your analysis, you actually would not want to go back to your boss with tables, right? Because it will be much more complex and not intuitive. So you need to like represent those findings in a graphical format so that it is easier to communicate your insights. Okay, so visualization helps communication easier for you. So let's move on to the next one. Next one here is informed decision making. So all those things are just obvious benefits that you should know once you understand what visualization does. So the other one we have here is data exploration. So during the exploratory part of your data analysis, you can actually use visualization to understand your data. So it's a tool that you can use during data exploration stage as well. So it can help you review unexpected trends and patterns that might be missed in textual analysis. Okay. So now let's move on to the common data visualization techniques we have. So for the first one, we have what we call line chart. All right. We have line chart. So this line chart is ideal for showing trends or changes over time. So let's say you want to know how a price of a product has increased over time. Or let's just come to our currency. Let's say you want to know how the inflation rate of our currency over the years, let's say over the past 20 years. You can actually use line chart to represent it in a graph. If you just put the raw data on your table and you put the percentage on a column and you put the years on a column, it's not like you won't understand it, right? If you actually pick through and like look at it intently, you would understand the pattern. But if you represent it in a visual format, a line chart can just tell you at a glance, you should know what is happening in a second, right? So if a chart cannot explain what is that, if you cannot understand what's happening in a chart within 5 seconds of looking at it, then that particular chart has failed in its purpose, right? So just keep that at the back of your mind. If you present a graph to an audience or to your stakeholder and they can't understand it in 5 seconds, that particular chart has failed in its purpose, right? So it's supposed to present its findings and insight clearly. So as you can see now, this is a chart that we have here, right? This is what this chart is basically showing us is sales, the amount of sales that has been made or that is being made over a month for a particular year, right? Which is 2020. Okay, we also have 2019, right? So it's just basically showing us the amount of sales that is being made for each month, right? So you can see here each of these points here corresponds to a particular sales for a particular month. So once you look at it, you should be able to tell that, oh, there's a particular trend going on. You can see we have an increase in sale and then a decrease, and then we have a slight increase, and then we have a deep drop in sales here in this particular month, and then we have a rise sharp. So now you can actually start analyzing this graph and say, why do we have a high decline in sale in this particular month, which is March? So these are questions that can arise from just looking at your visuals or your graph. So a graph should make understanding analysis insight very easy and intuitive. That is its purpose. All right, that is its purpose, and it should serve its purpose. If it cannot serve that purpose within a few seconds, it has failed. All right, so let's move on. So this is for line chart. Line chart is whenever you have time data. I think we're supposed to look at time. Okay, so don't worry, we're going to I'm going to find the data set that has time data so we can explore it with this line chart. All right, so but moving ahead, this is for line chart. It's just to show trends over time. It's just for time series data basically. All right, so the next one we have here is bar chart. So bar chart, this is the most common chart. Like probably you've seen this. If you've not seen it, maybe you're living under a rock or something. But anyways, just joking. So, but for bar chart, it's used to compare categories or quantities. So, when you have categorical data and you want to like compare a particular you want to compare those categories, you can use your bar chart. Let's say you want to compare the frequency of those categories. I want to compare it using another particular variable. Yeah, you can use your bar chart to do that. So bar chart is one of the most common chart that you use. All right. So in this case, we have okay, we have this particular bar chart here. So it's just probably comparing the frequency of animals, right? So we have dog is the highest. So we don't have a context to this, so we can't really interpret it. But this is what bar chart does for categorical data. Now moving on to scatter plot. Scatter plot is used to explore relationships between two variables. Okay, so when you want to assess a relationship between two variables, and in this case, the variable you're going to be working with are numerical variables, right? You don't use categorical variables when you use scatter plot. Okay, you don't use numerical and categorical variables when you use scatter plot. You use numerical variables. So when you want to see how the two numerical variables correlate with each other, you can just plot them in a scatter plot, and you're going to see how the data points relate with each other. So when we start looking at scatter plot, we're going to see what each pattern represents. So in this case, you can see that there is a direction in which this point is these points are headed from down to up. So we usually call this a positive correlation, that this height variable and diameter variable, they are positively correlated. Okay, that means there's a relationship between these two variables. So the scatter plot is used to really assess relationship between two numerical variables. All right, so let's move on. So we have pie chart. So pie chart is best suited for displaying proportions or percentages within a whole. All right, so very, very important. So it is best suited for displaying proportions or percentages within a whole. So let's say you have a particular variable and you want to know how you want to know it's just basically the same thing as bar chart for categorical variables, right? But there's a rule to using pie charts. Once your categories we have more than 5 categories in your data, it's not advised to use pie chart because it will become cluttered and to defeat the purpose of data visualization. One of the purposes of data visualization is to make understanding what you're communicating easy. So once it defeats that purpose, and once the thing that is happening becomes too much, it will be more difficult to understand that phase, all right, or that graph. So once you have more than 5 categories, you don't use pie charts. Just go for bar chart, okay? So pie chart is best used for 2 categories or 3 categories, or let's say highest 4 or 5 categories, right? But once it's higher than 5, just resort to using your bar chart. So the next chart we have here is your histogram. So histograms are used to reveal distribution of data within a specific range. So this histogram is actually a statistical is related to statistical technique, which is getting distribution of the data. So what we mean by distribution of the data is knowing how the data points or the different individual rows are scattered or spread. All right. So let's say, and this is peculiar to numerical variable. So I need you to be taking note of those B's that you can use for just numerical variables, because there are some B's that you can use for numerical variables. Like for example, histogram is used for numerical variables. Scatter plots for numerical variables. All right. So but for the other ones, we use mostly categorical variables, but we can actually make it bivariate by using 2 variables and trying to understand the relationship between these 2 variables. But we don't purely use numerical variables for line charts, bar chart, and pie chart. All right. So we're going to understand them better once we start demonstrating how we use these different charts. So this is your histogram. It's similar to your bar chart. For those of us that are not familiar with it, it's similar to the bar chart, but the only difference is that you can see that there's no space, right, within your histogram here, right? Because it's just trying to show us the distribution. So there's a concept in statistics that we call normal distribution. So if you're familiar with what normal distribution is, yeah, histogram is what you use to ascertain if a particular distribution is normally distributed or not. Because there are a lot of assumptions that a lot of things that needs to follow the normal distribution assumption for you to proceed with your analysis, right? So we're going to actually look at this more moving forward, but we use histogram to check if a data is normally distributed. All right, this is to check. We have different distributions. We have binomial, we have normal, we have Poisson, we have all of those ones. But the distribution that is more important is the normal distribution, and we can use it to ascertain if that data is normally distributed. So this is not a statistics class. If we start to pick up all the different fields in statistics and take them one by one, 6 months won't be enough, right? So I'm just going to explain those things that are needed at the moment, and then we can build on them. So we're going to look at I think this should be the last or second to the last, heat maps. So heat maps is another kind of chart that most of us are not familiar with, right? But it's actually an important chart. They're going to see more of these charts when we start machine learning, and especially when we look at what we call confusion matrix in machine learning and some other things. Okay, so what we this heat map do is basically to assess the relationship between two variables. Okay, so it's just like your scatter plot, but we have the first variable on the y-axis and the second variable on the x-axis, and we have different numbers here. So these numbers are usually used to indicate the relationship between these two variables are here. All right. So we're going to explore this more when we start looking at the application of heat map. So I don't want to waste time on it individual because it's just an introduction. When we start using them, I feel you'll appreciate them better. So the other one we have here is what we call box plot. So box plot is another kind of chart that is not so intuitive. Like most people don't really know how to use it or what it does. But this box plot is also used to assess your data distribution. The same thing with which chart did I mention earlier that is used to assess the distribution of a data. I just want to be sure that we're all following. Which chart did I mention earlier that is used to assess the distribution of a data or a variable? Okay, that's fine. Yeah, histogram. I just want the class to be interactive because this is an obvious answer. So histogram and box plot, they can be used to check for the distribution of a particular variable. All right. So we're going to see how to interpret a box plot, and I've explained the different quantiles, right? We have in a box plot. So the box plot is actually called box and whiskers plot. So this is the box here, this rectangular shape, right? And this extension here, they are called the whiskers. So the full name is box and whisker plot. All right, so it's used to assess distribution, and it's mostly used to detect outliers. All right, so whenever you plot a box plot, right? Every value should fall in between these whiskers, right? Most values should fall in. So any value you see outside of these whiskers, like if you see any dot here, just know that those are outliers, and that particular variable has outliers. So you should make sure that you deal with those outliers and use the box plot to check if we still have outliers before proceeding with whatever it is you're doing. Okay, so that's it for box plot, and that's it for the different kinds of charts that we are going to be looking at. So you can see we have a lot of charts to explore, but this list is not exhaustive. There are a lot of other charts that we've not talked about, but these are the most common ones, right? So, but once you understand the basics of visualization, you can actually just apply it to every other chart that you probably come across for the first time. So there's one thing I need you to note. Let me come and see if I can just. There's something I need you to note, that you must be aware of, or let me just say, different charts or graphs are sensitive to the data type you are working on. So you can use a chart that is supposed to be used to represent categorical variables on a chart that will be used to represent numerical variables. So you need to have an understanding on the kind of data that this particular chart works with. Very, very important. So different charts are sensitive to the data type you're working with. So if you use a different data type, let's assume you want to do scatter plot now, you're trying to use categorical variables. It doesn't even make sense, because the scatter plot inherently compares numerical variables. So it plots it and shows you the data point and all of that. So it won't work actually, right? Especially when you use Python, you're going to be getting errors. All right. So this particular Matplotlib is a kind of abstraction. There are a lot of things going on under the hood to kind of work with data and represent it and display it to you as a graph. All right. So we are going to look at how we use Matplotlib, but I just need you to take note of this. So let's just move on. So what do we have here again? So we're going to look at Matplotlib's core concept. So now we've moved away from we've actually looked at what data visualization is. We looked at common data visualization techniques, which are the different charts I have showed you. Now we're going to look at Matplotlib's core concept. So let's look at how Matplotlib works under the hood, or what exactly it does. So remember, when we introduced NumPy, we looked at how NumPy works, how array works, and all of that. Then we looked at pandas, we looked at data frames and series and how they work and all of that. So Matplotlib doesn't necessarily have a unique, it doesn't have a data type in the same sense as NumPy and pandas, but it has some things that makes it work under the hood. And we're actually going to look at that. So there are a few of those that we're going to look at, or some of those. We have figure, we have axis, we have plot, we have subplots, we have axis objects, all right? And we also have some things like legend, color maps, annotations, and collections. These are just like additional stuff. We're not really going to look at them. But the core one we're going to look at the axis object, subplots, plot, axis, and word figure. So once you understand these core concepts, you should be able to work with Matplotlib. All right. Once you understand this core concept, you should be able to work with Matplotlib. So let's move on. So what is figure exactly? So figure now is like the overarching container. Let's look at it as a canvas. All right. Right? It's like if you're an artist now, before you start painting whatever it is you want to paint, you bring up a whiteboard or a white sheet or whatever it is that you're working on. That stuff, that white sheet is your figure. So that is like your container, the container that holds every single thing inside your visualization. So when you have a visualization, just know that every of these single elements is on top of a figure. So the figure here is a top level container that holds all the elements of your visualization. So your visualization has several elements. So everything, they are packed into your figure. Okay. So as we proceed, we are going to look at how we can actually define our figure, how we can actually set the dimension for our figure and all of that. So as you have it here, just imagine your figure as the canvas on which you will paint your plot. Okay. A single Matplotlib session can have multiple figures. So what this basically means is that if you import Matplotlib, you can actually create as many figures as you want, right? Because obviously you most likely be creating multiple plots in the same session. A session in this case is like a notebook, right? So it's like creating a notebook and importing Matplotlib. That is a session basically. So you can have multiple figures in one session. So that's it for figure. Let's look at the next thing. So the next core concept in Matplotlib is your axis. So your axis is basically the x and y coordinates. So this is very easy to understand. Like we'll be looking at x-axis and y-axis, all this y. So your axis is the coordinate system that defines the x and y axis for your plot. So that's basically what your axis are. And you can actually work with your axis in Matplotlib. You can define what your axis, which data will be on your y-axis and which data will be on your x-axis. Okay, so each plot within a figure, we're going to look at what a plot is in a second. So each plot within a figure has its own axis. You can actually now determine the scaling and how you can label your data by working on each of those axes, right? So think of the axis as the grid system that provides a framework for plotting your data points. So if you plot a grid, you know what a grid is like, a horizontal and vertical line across a particular plane. So where the vertical lines are the x-axis, while the horizontal line are the y-axis. So that's basically what axes are. You can actually also work with it in Matplotlib. So the next thing we have here is plot. So a plot now is basically that thing that you are seeing. The line that you are seeing, the bars, the scatter plot, all of those are the plots basically. So the plot is a specific data representation within a figure. This could be a line chart, a bar chart, a scatter plot, or any other visualization type supported by Matplotlib. So that is what a plot is. As simple as that. A plot is the particular type of representation you want to use. So the representation might be a line, might be a bar, might be a scatter plot, it might be histogram or what have you. Okay, that's what a plot is. So you can see, let's go back to this axis. Each plot within a figure has its own axis. Now, when you make a plot, before you have a plot, you have to define the figure. After you define the figure, you have to define the axis. So once you define the axis, then you can now define the plot inside that axis. So there have to be a plot there have to be an axis before you have a plot. You can't have a plot without an axis. That's why we say each plot within a figure here has its own axis. This statement here is actually very key and very important to note. So another thing you need to know is that you can have multiple plots within a single figure, each with its own axis. All right? You can have multiple plots within a single figure, each with its own axis. So that's what we call subplot. So we've talked about plots. We now look at subplot. Subplot is like having multiple plots inside an axis, inside a figure. Let me see if I can just show you subplot in Matplotlib. So let me see if I can just get some email. I don't want to show you exactly what subplots look like, because just explaining it might not really make a lot of sense, right? Okay, let me. I think this one is. Okay, so let's see this. Hope everyone can see my screen clearly. Hope everyone can see my screen clearly. All right. So as you can see on the screen here, we have. I'm just going to use this to explain everything I've just explained now. So this is what we call subplots, right? This and this, we have 6 plots here, and 6 of these plots, they are inside. Or let me just ask everyone before I say it. Let me see if we are following. So how many figures do we have here in this particular plot, in this particular chart that we have? Exactly. So we have just one figure. Someone is saying, "Can I be audible? Am I not audible enough? Please let me know. I need feedback. Do I need to increase my voice, or is it okay?" All right, fine. So the person should probably just check their speaker to be sure that it's on the highest level. So now this is what we call subplot. It's on a single figure. So as I said, one figure. This is everything that you're saying here is on top of a figure. That is one figure. Now that figure can contain multiple plots. So we have one plot. This is one plot. This is another plot. This is another plot. This is another plot. So we have 6 plots in general here. And each plot, subplot. So we call this subplots, right? We call each of them subplots. We have 6 subplots here. So on each subplot here have their own individual axis. So this is the y-axis for this subplot. This is the x-axis for this subplot. This is the y-axis for this subplot, and so that's basically what this statement here. That's basically what this statement here means. That where is that thing again? So each plot within a figure has its own axis. That's what I wanted to show us, right? So you understand what exactly this statement means. So let's move forward. And you can see you can have multiple plots within a single figure, as I've just shown you, each with its own axis. So it's either you just have one figure and one plot, or you have one figure and multiple plots, depending on what you are doing. So then let's look at subplot. Subplot is what? A way to create multiple plots within a single figure by dividing the figure into a grid of subplots. So when you create your figure, you can now divide that figure into a grid of subplots, and then you now work on each grid by plotting your different charts on it. Okay, that's basically how you create subplots in your figure. So this thing now is not very easy to perform or to do in, let's say, Excel, right, or other visualization. So what you normally do in other visualization is like creating a dashboard and like putting different charts there, all of that. But you, in programming languages, you have more flexibility to define what exactly it is you want in your figure. So that's one of the advantage of like of Python and using programming for your biz, right? So the last thing we have here is what we call artist objects. So everything that you see in Matplotlib plots, including lines, markers, text, labels, titles, legend, etc. Every other thing, they are represented by an artist object. So that is basically what an artist object is. Every other thing you can actually customize your plot by including other features in your plot, so it will be very appealing and look presentable. So all of those things that you can do to customize it, they are just artist objects. All right. So these objects have properties that you can customize to control appearance and behavior. While they are not essential for basic plotting, understanding artist object allows for fine-grained control over your object. So they are actually not essential for, you can actually do without artist object. You can just plot your piece, but it won't really make sense like just leaving it like that, because it would enhance understanding, right, on the audience end. So these are the things that you need to know. These are the core concepts in Matplotlib, right? So I hope you all understand all these things that have been explained, so we can just move forward. So I think we have some other things. We have additional concepts here. We have what we call legends. So legends are used to identify different data sets. Like, so these are the things that you should know normally, what legends are. We have color maps. Color maps are a way to change the colors of your views. If you don't want blue, you can change it to red, you can change it to green, you can change it to any color that you want, basically. So you have annotation, you have collections. So all these things are just added bonuses in Matplotlib, all right? So you can look at them and just check them out. So by understanding this core concept, you can effectively create informative and visually appealing visualizations with what? Matplotlib. All right. So that's basically about that. So I hope with this you kind of have an understanding of Matplotlib and the basic or the core concept. So we're now going to be moving forward to how to now use Matplotlib. We've looked at the theory aspect. Now is for the how. We've looked at the what, right? What is Matplotlib? Now we'll now look at the how. How can we now use Matplotlib? So using Matplotlib for data visualization in Python. All right, so now let's quickly go back to our sheet here. So using okay. So the first thing first is what we are going to import Matplotlib library. So since we are using an account that we don't need to download or install it, we can easily just import it by using the normal import statement. So come and say import Matplotlib. Right, this is what we've been doing since, right? We import pandas as panda, as pd, import numpy as what? NP. But it's quite different from Matplotlib actually. So we don't come here and say import Matplotlib as, let's say, maths or plot, or let's say as math or as whatever alias you want to use, right? But we want to actually import a module inside Matplotlib. So that module is what we're going to be using to plot our graphs. I need you to understand this. We actually have to import a module inside Matplotlib. We don't import Matplotlib directly. So if I import Matplotlib, I'm not going to, the functions and methods would not be what I will need to plotting my graphs, right? So I need to import a module. Remember when we're importing NumPy, there is a particular module inside NumPy called, can someone remind me? There's a module that we looked at inside NumPy that we actually imported. We said from NumPy, import this. Can anyone remember that? I'm not talking about Matplotlib, I'm talking about NumPy. I just want to give us an example as with NumPy. Nobody has gotten the answer yet. Pascal, leave attendance and answer the question. Attendance will be open. Don't worry. Let's focus on the major and most important thing. So we've all forgotten NumPy. It's not been up to 1 month yet. Anyways, so basically when we looked at NumPy, there was a module called random module. Let me just come here again. There's a module called random. Remember in NumPy we work with random number generation. We said from NumPy import random. Did I do something like this, or am I missing it? Did we do anything like this in NumPy? I don't want to be sure. Remember when I did random and I came and I said you can create random values, like you can say random.rand int, all right, something like this. If I run this, I should run this first. Let us just quickly run. All right, remember I did something like random.rand. Let me check. You can see that I showed you how you can generate random numbers. We have random.rand, we have random.rand, we have random dot with a whole lot of other things inside the random module. Remember I did this, right? Am I like mistaking it for something else? I can remember vividly that I did. I showed you how to import random modules and use the random functions in NumPy. Some people are saying no. Do you want us to to go back to it and show you exactly where I demonstrated it? That just, I probably think you either you didn't attend the class or you've forgotten, right? But I'm very sure I did that. We did random number generation. That was actually at the end of NumPy class. So I demonstrated it in manual. And then go back to the video. Anyways, let's just proceed with it. So what I was trying to bring out here is that we can actually import a module from a library. All right. There are some particular functionalities you want to use, but you cannot find them directly in that library namespace or that library. So you have to import something else inside the library. So that's the same thing we're going to be doing for Matplotlib. So for Matplotlib, we will not import Matplotlib directly, but we're going to import something else from Matplotlib, which is called pyplot. So say from Matplotlib, import pyplot. So this pyplot is the particular module that we'll be using to plotting our graphs and charts and doing a whole lot of other things. All right. All right. Let's just move on. So just that's just a good refresher. At least I probably might not have emphasized it, but it's a good thing that I brought it up so you remember it. So for Matplotlib, you import pyplot. So pyplot is a module in Matplotlib that you would use in plotting your graphs. All right. So as we are always going to do, you have to create an alias. So for Matplotlib.pyplot, you can just come and say plot. So this plot is going to be what you'll be using as the alias moving forward. You can either import it this way, which is the method 1. Or you can say import matplotlib.pyplot as plot method 2. So these are the two different ways to import pyplot from Matplotlib. So what you are going to be working with is what pyplot, okay? So now this PLT, this plot here is now representing pyplot. So this plot is what we're going to be using moving forward in Matplotlib. So if I come and say plot, this is what a module. You can see it's a module in Matplotlib. All right. So I can come here and just say print dir and then plot. The attendance is open now, so you can all start signing and marking your attendance for this class. All right, so if I do print the plot, you're going to see we have a whole lot of stuff here. So everything you're going to be working with, they are inside this plot module. So we have all the plot. Let me just look for one of them here. You can see we have box plot here. We have box plot here. We have what is bar? We have bar here. We have line. Let's see, scatter. We have scatter plot here. All right. Where's histogram? We have histogram here. So we have all the plots that we've looked at. We have them here. So we are going to be working with PyPlot module, plotting everything that we are going to be plotting. So there are a lot of other plots. See volume plot, we have volume plots here, which we didn't look at. So it's left for you to just like play with them and see what exactly you can bring out from it. So that for PyPlot. So PyPlot is the module we'll be using from Matplotlib in plotting and doing everything we're going to be doing. So let me just at the same time introduce Seaborn. So I don't do that later. So Seaborn is another library. Importing Seaborn. So Seaborn is another library in Python for visualization. So Seaborn is like a library that is built on top of Matplotlib. All right. So it makes plotting way more easier. There are a lot of things you don't even need to even do on Seaborn because it has been done for you under the hood. But in Matplotlib, you still be doing some tweaking and fine-tuning and all of that. But in Seaborn, you don't need to do most of those things. So you can just come here and say Seaborn as the alias for Seaborn that we normally use is what we call SNS. So for Matplotlib or Python, we use plot. For NumPy, we use NP. For pandas, we use PD. For Seaborn, we use SNS. All right. So that is the alias for Seaborn. So if I come here and I change this to SNS, you see that. Let me run this first and run this. So this will take some time to load. So basically, let's just go back to the material. So now, as I've said, we would import Matplotlib first, and this is how we can import Matplotlib. So the plotting aspect of it is from PyPlot. Anything that has to do with plotting is from PyPlot. So there are other things you can do from Matplotlib. So there's what we call styling. So if you want to decide or use a particular style in Matplotlib, you can import style from Matplotlib directly and change the style that is going to be used throughout your plotting. All right. So let me show you what I mean by that. So if I come here, so this is Seaborn generally. So these are the attributes and methods for Seaborn. So you can see the different plots we have here. Where is our scatter. So this scatter plot for Seaborn. We have this is a histogram, hist plot. This is heat map. All right. Which one again? We have line plot. This is line plot. We have you see volume plot again here. We have swarm plot. We have a lot of stuff here. All right. So this is just to show you that Seaborn is also used to plotting. So I'm going to be showing you Seaborn and Matplotlib at the same time, so you kind of have a better understanding of both of them. All right. So, but for Matplotlib, when you set up a Matplotlib, you can actually choose your style before you proceed. So let's come and say choosing our plot style in Matplotlib. So remember I said you can also do the same thing in Seaborn. You can set your theme in Seaborn, but let's look at Matplotlib first. So to set your style in Matplotlib, you have to import style from Matplotlib. So I'll come and say import, or I can say from Matplotlib import style. All right, so we are importing style. Style is a module again. Let's just say it's a module from Matplotlib that we use to change our style. So what the style basically means is that any plot or any graph or any chart you'll be creating using Matplotlib in that your session is going to follow that particular style. All right. As we move on, you're going to understand better what I just said. So now you can come and say style. Let's see what style is. So style is a what? Is a module. If I come here and I shift tab, is a module, the same thing. So if I come and I say print dir and say style, you see that basically these are the things that are in style mode, not plenty. We have available, we have context, we have core, we have library. So the two most important attributes you'll be using or functions are available and what use. Available and use. So what this available does is that it tells you the available styles in Matplotlib. So if I come and I say style.available, you see that we have a list of styles, right? You can see we have a lot of them. We have the solarized light, classic, blah, blah, blah. We have BMH, we have classic, we have dark background, we have fast. So we have a lot of them. You can see we even have Seaborn styles here. Seaborn version 0.8, Seaborn D, Seaborn that, and W colorblind. So these are the styles that we currently have in Matplotlib. So we can use any of these styles in okay, we can't sign attendance. Let me confirm again. Has anybody been able to sign attendance, to mark attendance so far? Please let me know if has anybody been able to mark attendance so far. Okay, yeah, if some persons have marked, then it should work for every other person. So just try again. It's actually open. All right, that's fine. So let's proceed. So we have all these styles here. So to use any of these styles, you can just come and say, let me see. Let me create a new. I'll say using a particular style for our plot. So I'll come and say style dot what use. Remember I said there are two of the, we have an attribute here, available, and we have a method here, use. So this available will show you the available styles, while use is going to what? Is going to help you use a particular style. So let's say you want to use dark background now. So I'll just copy it here, dark background, and come here and just paste it, dark background. So once I run this, it is going to apply to all the plots that I'll be using moving forward. I don't need to run this again. Once I run it, any style I create in Matplotlib is going to conform to this style that we have here. So if I change it, it's going to change. So it's going to like apply to every other chart. So that's basically how we can customize our style in Matplotlib. All right. So that's basically it for that. So you can see we have it here. I think we can. The one I like most is ggplot. So ggplot, if you've used R before, graphs and charts. So you can use ggplot style, you can use Seaborn, and you can use any other one that you actually you're actually interested in. All right. So for now, let's just use that background, and I'm going to change it and show you. So let's move on from there. So the next thing we have on our material is what? Creating our data, preparing our data. All right. So in this case, we are going to I'm going to try to import a data so we can demonstrate all of these things that we are doing. So let's see. So, but first of all, let me just use mock data first so as to like demonstrate all of to just demonstrate it basically. So let's see. Let's create the data first. So we have X and Y. I'm just copy this. Right. So creating our data. So I'll paste this. So we have two variables here. We have X variable and we have Y variable. So now we actually want to plot a line chart. Right. Let me start from plotting a line chart. So now to plot the line chart, we're going to use the plot module. So remember, I've imported pyplot as what? What did I import pyplot as again? Can someone just remind me quickly? What did I import pyplot as again? As plot, all right? So I imported pyplot as plot. So I'll come here and say plot dots. So I want to access the methods of plot. So we need to know the particular method we're going to use in creating a line chart. So the method for creating a line chart is what? Plot. All right. So if I come here and I put this, so what does this say? Say plot x, y versus x as lines and or markers. All right. So that's basically what this plot does. So if I come here and I say plot, and I say y, and I say x, and I run this, you see that it has created something for me here. Right? Can you see it? I've actually, let me zoom out to see it. I've actually created a plot. So this plot doesn't really make sense because it's just a random value. If I change this value here, let's say I change this to, let me just make it going, let's just make it to increase. So 1, 1, 2, 2, 3, 4, 4. So this is a line chart, all right? You can see how it's moving straight because of the data. So it's basically representing the data that we have here. If I change this, let's say I change this to, let me just copy everything and put it in the same place. I'll come here and say 3 points. I want it to come down. Okay, let me make it to be what? 3, or let's say 3.5, and make this one to be what? 2.5, and then make this one to be 4 and 5. All right, let's see what it's going to give us. So you can see what we have here, right? Basically, so it's just giving us the exact, representing the exact values that we have. So you can see the style of this Matplotlib now. It is what? Dark background. If I come here and I change the style to, let's say Tableau color blind, I copy this style and I put here, and I run it, and I run this chart again. Let me run this again. All right, let me see another. Let me try another one here. Seaborn. All right. So you can see that we have a different style here. All right. So depending on the style, you would have your charts like looking differently. All right. So I feel this Tableau color blind and this dark background, they are basically similar style. I don't know. But the one I like the most is ggplot. So ggplot, come here and change it to ggplots. And then run this. So you can see how like it basically just formatted the graph and it made it look actually nice and all of that. So this is the bare minimum you can have. Can we use different background interchangeably? Basically, you can actually. So once you run, but the thing is just going to, you just need to know like in which order you execute yourself. If I use ggplot here and I execute this chart here, it's going to be ggplot. But if I now want to like moving forward, I now want to use another style, I can basically just change this new style and then run the subsequent plot. It will give me a plot in that new style. But I will make sure that I don't rerun this cell again. Because if I run this cell, it's going to apply the new style that I have. So in a way, you can actually use different plot and all of that. But is the best way to do it is just to use a style that will apply to all the charts that we are going to be using, right, from top to bottom. So that is just it. So let's move on. So you can see this is an easy way to like create a line chart. Let me make this even more interesting. Let me just make it longer. This is going to be a mess, but let's just see. We have 1, 2, 3, 4, 5. We have 1, 2, 4, 5, 6, 7, 8, 9, 10, 11. 6, 7, 8, 9, 10, 11. All right, so you can see the kind of chart we have here. So let me see if I can change this. So this one is here. All right. So let's just leave it at this. So I just want to show you some other things that you have around your chart. But once you have your plots, this is your plots. So this is a figure basically. You had your figure already, and everything that you are seeing here is on top of the figure. You are not seeing it, but once you use plot function, this PLT function to plot any graph, automatically a figure will be created for you. So you can actually create your figure on your own. You can actually customize your figure, and it would allow you determine the dimension of your graph or your chart. So let's say I don't like this size of chart. I want this x-axis to be longer, and I want my y-axis to remain the same or to be maybe shorter or something. I can actually come and determine and define my figure. So I can come here and say defining my figure. So let's quickly see if we have it here. All right, let's just move on. So the function to create a figure is plt the word figure. So everything you are doing and that is going to be relating to plot is from plt module. So plt.figure. So let's see what plt.figure does. So this basically creates a new figure or activates an existing figure. So we have the different functions here. We have the fixed size. So the fixed size here is what you're going to actually determine yourself. So it's usually a tuple of x dimension and y dimension. So if I come here and I say fixed size, I'll say figure, and I come and I say fixed size is an argument in our figure. Fixed size equals to, and I'll put 8/4, and I run this. I'm going to say that the figure has changed, right? You can see how the x-axis is now longer than my y-axis, all right? So if I change this 4 to, let's say 5, so this 8 here corresponds to what axis, and this 5 here corresponds to one axis. I need quick responses on this. What does 8 correspond to and what does 5 correspond to? I'm doing this just to kind of create an interaction with the class here. Someone asks, can we use NumPy to generate the arrays for X and Y coordinates? Yes, of course. Like you can generate whatever figure or value you want for your X and Y coordinates. You can do that. Can we use style inside the figure? No, you can't use style inside the figure. You create your style separately. You don't use your style inside the figure, right? So, but you can actually do other customization. All right, you can change your edge color and a lot of other things. So let's see that. Let's change edge color. So most of these things you will really not even use it, but let's see. So let's see face color. Why is it not doing anything? Face color. All right, so we're having red here. Let's see blue. So you can see now where the figure is. You can see that the figure is at the background. So this blue this color that we have here is just kind of giving your figure a color. So this blue stuff, colored object is the figure at the background. Why this x-axis and the plot and every other thing, they are on top of the figure. So I feel this is going to give you a better understanding of how figures, plots, and axes are related. All right, so this is basically what a figure is. So yeah, 8 corresponds to the x-axis and 5 corresponds to the y-axis. So you can even make this to be 10 and 5. So you can see that it's now longer and bigger. All right. So let me terminate it at this point. 25. So I'll just change it 25, 14. Let me make this make this y bar. And then we have 24. And here I can have, let's say 15. Let it drop a little from 10. Let's say 20. And here we have, let's say 22. Okay, so we are going to have something like this. So you can see this is a nice looking graph. So it starts from here and then comes here and then. So if there's a data at the back of this graph, you probably understand what the graph is saying better. So this is how you can customize your figure and how you can also plot your chart or whatever. In this case, a line chart. So this thing you are seeing here, Matplotlib.lines and all of that. To avoid seeing this, whenever you make a plot, there's a function that you always do at the end, plot.show. So this plot.show is a way to like display your plot, but because you're in Jupyter Notebook, it will show it regardless without even using plot.show. But it's advised, a good practice for you to always use plot.show at the end of plotting your graph. So you see that we don't have that stuff here again and all of that. So now let's start looking at how we can actually customize our charts. I'm going to use line charts here and show you how we can do the customization and then move forward to showing you how we can do or customize or create other kinds of charts, right? So in this case, we are going to look at plots. So we have a lot of things that we can do with the plot module. All right, so if you scroll down here, let's see. They give a lot of other examples. So we have what we call markers. Let me see. So we have what we have some arguments here. We have color argument, we have marker argument, we have line style argument, we have line width argument, and we have marker size argument. So these are the different things you can use to customize your plot. So in this case, we have just X and Y arguments. So now we are going to try to put including all these other arguments. So I'm going to come here and just copy and paste them. All right. So you see that we have a lot of stuff going on. If I run this now, we're going to get an error because we didn't put a comma somewhere. All right, let's see. I do. All right. So, all right. So let's run this. You're going to see we are going to have something like this. So you can see how we are now customizing our chart. So we are now like customizing the plot itself. So this color has been changed from what the default color red to what green that we like indicated here. So this marker here is this particular marker is going to be what we are going to have here. So it is rounded. So because we have 0 here, so you can know the different markers we have by just coming to plot, shift tab, and coming to the markers. You can see if you scroll down a little, we are going to see all the markers here. We have our markers. We have point markers, we have pixel marker, we have circle marker. So the marker we are using is circle marker. We have a triangle down marker, we have triangle up, we have so we have a lot of markers basically. Yeah? So you can basically like just come here and look at the markers. So let's look at some of these markers. Let's look at the asterisk markers, let's look at the pixel marker, let's look at the points marker. So I'm going to change this to asterisk. I'm going to run it. You see that the circle has changed to what? A star. If I change the marker size, let's change it to 5. It's to be more reasonable. It's too tiny, right? Let's change it to 10. So you can see the marker here, right? It's smaller than before, but it's more reasonable. So let's change the marker to something else. Let's change it to, let's say, we have the pixel marker. So I'm going to put that. So let's increase it. Let's say 20. All right, I don't know whether it's showing, but let's try other marker. I think we have P. This is P. This is for hexagon. We have. Let me change this to 10 to be more realistic. So let me change this to S. We have S here. This for square. We have triangle up. Where is my triangle up? So we have a lot of markers that you can use. Basically, you can change the width, the size of the marker, and the marker itself. So we also have color here. We can change our color to whatever color we can think of. Any color you can think of, you can change it to that color. So I'll come and change it to let me see if violet would even work. So any color that you can think of, it would work basically. So if I change it to let's see if gold will work, right? Gold, it's like anything you can think of. Let's say you are doing a project and there's a color map that you're supposed to use. So you can just align the color of your plots to the particular color palette that you've been given for that. So that's the interesting thing about using Matplotlib. It is very, very customizable. So this is just, we're just scratching the surface at this point, right? So let's just leave our color at, let's leave it at orange. Let's say orange. All right. So let's leave orange. So now the line style is another argument that we can customize. Okay. Let's say I want to customize my my line style. If I come to plot, I should see all the different line style I have. Let's scroll down. You see we have line styles here. We have the dash, we have dash, we have double dash, we have dash and this, we have this. So you can just select any of them. So let me see. Let's use the dash. If I use dash, it's okay. It's still the same thing. Let me use dots first. Let me see dots. Okay, I don't know why it's taking time, but possibly it's trying to understand dot, and dot is not a valid value. All right, so you can see that if you use an invalid line style, it will give you an error. Dot is not a valid value for line style. The supported values are this: dash, 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 dash and dots, colon, none, this, solid, dash, dash, dot, and dotted. So let's look at dotted instead of just using dots. I'll say dotted. So you can see we have dot instead of dash. Let me go back to using this instead of this triangle and changing this to, let's say, 7. All right, so you can see that we can change our line style here. Let me use this colon here. You can see we have this. I think we have dash and dots. Okay, see dash and dots. So there are a lot of things you can change to customize your chart. So this is just for line chart alone. All right, this is just for line chart. We have the different I'm going to go over the questions in the group to see if anything. Can the line and marker have different colors for each? No, No, the color here is a general color. So once you have color, everything is going to have align with that color. All right. Yeah, I think so. Let me see. I think there are no other arguments here that would allow you to customize each default. Let me see to be sure, because the truth is that this Matplotlib has a lot of customization that sometimes I probably even miss some of them, because it's not something like it's not like you'll be using every single thing. So, but let me just leave that. Just figure that out on your own. It will even help you to learn more. All right, so this for line plots, right? These are the little customization that you can perform on your line charts. Now let's look at some other things you can do. So let's say I want to give my plot a header or a title. You can come and say plot.title and then give it title. And say a simple line chart. All right. If I run that, you see that it's going to give my chart a title now, a simple line chart. So it's just going to put it on the top here. All right. And let's say I want to label my x-axis. I can come and say plot.xLabel. Come and say x-axis. For y-axis, I'll say y-label rather. And I'll say y-axis, all right? So if I run this, you see that my y-axis now has been labeled, and my x-axis. So this is basically a typical example of a descent chart. So this is what you would most likely be doing. You have your plots, you have your x-axis, you have your y-axis labeled, and all of that. So this is how you can actually create charts using Matplotlib. All right. So this is a very straightforward, simple plot in Matplotlib. So let's look at the other kind of chart we can perform. So moving forward, we are going to just try to use custom data. All right. So tomorrow we'll probably use a data set to demonstrate how we can plot using our data set, right? Or use the data set we've used in yesterday's class, because I think the time is already running out and I won't be able to go into that. So I'll just introduce you to how we can actually use Matplotlib and plot all the different charts and graphs. So let's look at plotting a bar chart using Matplotlib. All right. Let's go to our material here. So you can see that we've actually been able to do this. Is for histogram. Let's go to line chart. This is for line chart. These are the things that you can actually do, right? Okay, so let me just show us how to do this. So there's I don't think I should just introduce this now so as not to complicate the whole thing. So let's just stay there for now. Let's go to bar charts. All right, we've learned how to create a line chart, right? So let's go to bar chart. So when to use bar chart? Use bar chart when you want to compare discrete categories or quantities. Let me repeat that thing, what I just said. You compare using bar chart when you want to compare discrete categories or quantities. Let's say you want to compare sales figure across regions, or you want to compare product popularity, all right? Or you want to compare the states with the highest, or the GDPs of different states. So let's say you have 7 states and their GDPs, and you want to compare the different GDPs. You can use a bar chart for it. It's actually going to give you a very good representation of that. So you have this happens when you have a limited number of categories, because when you have a lot of categories, let's say 50 categories, it won't make sense to use bar chart. It's going to kind of clutter the whole thing, and it will be messy and all of that. So it's usually good when you have a discrete number of categories. Let's say if you have 20 categories, I think it will still kind of perform well. Like you will still be able to notice the different categories discretely. All right. So let's just move on to how we can use that. So we are going to create categories manually. So we have let me just go back there. So the function we use for bar chart is what? Plot.bar. All right, let me zoom in. Plot.bar. So remember for line plot is what? Quick answer. For line plot is what? Okay, someone asked, does the marker mean intersection? Yes, the marker is the intersection between the two axes, right? Because you're actually comparing, or you're actually marking a point where X and Y meet. So that intersection is where the marker actually draws that particular sign. So yeah, you are correct. It's the point indicated by X and Y axis. Yeah. Who has that question? Emmanuel, yeah. Plot.plot, right? That's fine. So that is what we use for line plots. So this might be confusing because line plot is not there. So you need to know that plot means line plot. So let me, as I said, I'm going to be using Seaborn and Matplotlib. So for Seaborn, if you want to plot a line plot in Seaborn, I can come and say sns.line_plot. So you need to learn the different functions for plotting. So if I just do my shift and tab here, you see the different value arguments. We have X argument, we have Y argument, we have hue, size, and all of that. So I can come here and just say X and Y. If I run that, okay, let's see where this one is. So I need to get the exact arguments. So we have data, we have X, we have Y. So okay, this Seaborn, we're going to use it when we start working with data actually. All right. So because this actually looks at a data, which is our data frame, and assign this X and Y to the columns. So we're going to look at that when we start looking at data frame, but let's keep that for now. So for bar chart, we'll come and say bar takes what? It takes your X, right? And it takes your height. So your X basically is like the values that you would have. The category is basically while your Y will be the point of comparison. So let's say we are comparing, what am I going to compare now? Okay, let's say we want to compare the different classes in CareerEx. So I can say CareerEx, and I will say let me just say classes rather. Classes, I'll say data science, I'll say cyber security. I come and say product management, and come and say product design, can say backend development, can say last one here should be front end. So these are the different classes programs we take in CareerEx development. So I'll now have the number of students. I'll say number of. So I want to compare the number of students for each classes. So I have 5 classes. So I can come and say for data science we have 400. Cybersecurity we have, let's say, 350. Product management, let's say we have 100. Product design, let's say we have 70. Backend development, let's say we have let's say 80. Front end, let's say we have 150. All right, so these are the data we're going to be working with. So we can now come here and put our data. So for X is our label. So our label is going to be classes. Y height is going to be the value that we are comparing. So it's going to be number of students. All right. So we're going to run this. and it's going to give us a bar chart. So you can see that we have a bar chart now comparing all the categories. So you can see now the labels are kind of just all over the place because they are lengthy and the figure is not long enough. So there are two things we can do here. We can actually, so as I said, always put plot.show, all right? So to remove that stuff that is always showed here. So there are two things you can do. You can actually increase the figure length. So I can come and say plot.figure, and I'll say fig size equals to, I can say 15 by 7. All right. So it's going to actually extend it, and you see that we are having everything appearing distinctly. Let me zoom out. So you can see it now. You can see all the different categories here, and everything like appearing like neat and all of that. So this is the first option. The second option we can do is rotating the values. We can actually rotate our values to any angle that would make everything to be separated. So I can come and say to do that, there's a function. It's called, I think, X label. So I think we have a function. Let me just be sure. We should have a function called rotate. All right. Okay, I think it's not X label. Let me check S label just to be sure. Rotate 45. Okay. Sorry, it should be S6. So we have another function called S6, right? This S6 actually does this rotation for us. It has a function called rotate. So if you look at it, you would have something like this. I think the argument is rotation, not rotate. Rotation, not rotate. Okay, so this is the function. All right, so things that Matplotlib has a lot of functions and all of that. So, and yeah, so you have to get familiar with them. So we have S6. S6 is different from X label. Remember, X label is to label your X axis. Let's say X label. So this takes in a string, which was, so we're going to call the label for the X axis the classes. We're going to say classes. I'm going to do Y label. I'm going to have number of students, and then we're going to have our title here. So plot.title. So number of students in each class. All right, so if you run this, let me change this this figure size. So you can see that we have the whole thing formatted. So we have the title, we have the number of students, we have the X label, and we have the Y label, and we have the X label rotated to 45 degrees. So I can actually rotate it as much as I want. I can say, let me rotate it to 90 degrees. If I say 90 degrees, it's just going to be straight, you understand? So this is basically how we can just make everything to be decluttered and all of that. So that is how we can like perform our bar chart and create a bar chart using Matplotlib. It's straightforward. So it takes in two arguments, primarily X class, X which corresponds to the label, which are the categorical variables, while height is the second one, which corresponds to the value that you want to compare across each category. So if you have a data set, this X is going to be the unique values for your particular variable, while the height is going to be the variable. You're going to have to aggregate that numerical variable for each of the categories and then get the values and assign it. So there's a way you do it. We'll probably look at that in tomorrow's class. So you'll be able to like create your bar chart for your data in a data frame. So, but this is just a simple way to illustrate it. You already have them outlined here already. So, and we can just do it straightforward. So let's just try to see how we can like customize our bar chart. We have width. So the width is like the size of each bar. So I can come here and change the width. I'll come and say width equals to, by default is 0.8. So I can say 0.5. If I make it 0.5, you see that it's tiny, is more narrow, is narrower. I come here and I say 0.2. You see that it is even tinier. So if you have a lot of categories, it would be nice for you to kind of make the bars smaller. Or the thing is that by default, when you have a lot of categories, Matplotlib will actually align the width. But anyways, you just have the freedom to do as much as you want. So we have other parameters here. So let's see, we have align. We can align our bars on the x-axis, right? So we have other parameters. We have color, we have edge color, we have line width, we have tick label, we have label, we have cap. We have a lot of things here, so we can't really go over them. So you can play with them when you get this material. And let's just pick one from here and see how it works. All right. So let's look at color, right? So we're going to choose our color here, and I can come and say color equals to green. So it should be a string. I can say green. Let me remove this width. So if you put one color is going to be applied to everything. But if you want to give individual colors for each of the categories, I can actually do that. I'll just create a list of colors. So I can come here and say green, red, yellow, orange, blue. How many do we have here? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And we have, let's say, violet. All right. So we're going to just pass in the colors that we created and then pass it to this. So it should, what color is it saying? Okay. Red, yellow. Okay, this should be a comma here. So you can see that each of the categories now have their own specific color. So there are a lot of things you can do. You can actually give a color for the edge of these particular bars. You can actually give a color. So let's see that. So I can come and say edge color and say black. Let's say black. All right, so you can see now the edges have colors, right? So this is just me showing you the freedom you have to customize your bar chart. So the same way you can customize charts in Excel and other like softwares, is the same way you can do that in Matplotlib. So, but the flexibility is you have like more flexibility basically in Matplotlib, because it's basically programming. You are literally writing programs, so the flexibility is, it doesn't have boundaries. You can do as much as you can. All right. So that is just how to create your bar charts in Matplotlib. All right. So we can just look at how we can do other charts quickly before we wrap up today's class. So let's look at how we can create a scatter plot. Yeah, how we can create a scatter plot. So scatter plot is used when you want to explore relationship between two variables, e.g. correlation between height and weight, and then you have a large number of data points and you want to visualize the distribution. So let's quickly see how we can creating a scatter plot graph. So for scatter plot, we use plot.scatter. So this is the function for it, right? It takes your x variables and you take your y variables. So let's use the x and y variable we have initially, x, y. Then we can come here and just say plot.show. So you see that we have this scatter plot. Although we don't have a lot of values here, but let me see if I can just create more values. Let me create, we'll do np.range. So import numpy as np. All right, I'll show np.range and range. I would say from 20 to 100, and then I'll say np range. I would say from 100 to 120. All right, so let me just copy this. I don't know what that will look like, but let's just see. Okay, this is not the same size here. So let's see. Let me check the length of each. Print len x, print len y. 80-20. What was I even thinking? It should be 180. Okay. So you can see this is a scatter plot. Basically, it's a almost perfect scatter plot graph because each because of the kind of values that we have here. But this is not an ideal way to show us a scatter plot, right? Let me still use the former one we have here. So because doing this thing manually will just take a lot of time. That's what I'm trying to. So let me just make it 30, 20, 3, 4, 5, 6, 16, 4. Now I'm going to do something. All right. So I'm going to come here. How many did I? What do you say? 6, 14, 15, 20, 22, 4, 6. All right, so let me just check the length of these two, and then get the length. I'm going to remove this for now. We have 23 and 20, so I'm going to add 3 more, 4, and 7. All right, so the lengths are the same. So make sure the length of your variables are actually the same for scatter plot to work. So you can see this is a scatter plot basically. So there's a reason I did what I did. So you can see we have most of the values. We have most of these values coming to this particular left-hand side because of some high value. So remember I told you that scatter plot can be used to check for outliers the same way as box plot. So when you create a scatter plot and you see values that are deviating significantly, that are not together in the same cluster with your other values, those values are potentially outliers. So if you like create a scatter plot of a variable and you are seeing something like this, you are seeing values that are clustered in a particular position, and then you are seeing another value that is staying alone, distant from other values, this should tell you that this is an outlier. All right, so you look for a way to remove that outlier. So let's remove it. This outlier here is 100. Let me change it to 10 and I run it. You see that now the data points are actually coming together to fill the entire graph. But we still have some here. We have this one that is here and we have this one. So let's try to remove these two. I think 30 and 45. So let's see where 30 is. Okay, this is 45. Let's make it, let's just make it 25. And we have 30 somewhere. So where is it? 30. Okay, we have 30. Let's just make it 10. So I'll run this again. You can see now that the data points are actually evenly distributed. There's no data point that is deviating significantly from the other data points. All right. So this scatter plot shows us a pattern. The pattern is not really clear, but from this you can actually deduce a pattern. You can deduce that there's a slight movement towards the right hand side going up. So if you draw a line here, the line is going to go like this, which shows you or tells you that there is a positive correlation between X and Y variable. So you can now see how we can use this scatter plot to assess the relationship between two variables, right? So I've showed you how we can use it to like detect outliers and potentially identify those outliers and remove them, and plot your scatter plot again to make sure that you don't have any outlier again in your data set, right? So you can also use it to assess the correlation, right? So once you see this, there's actually a slight positive correlation, but to back this up, you would need to perform statistical tests using Pearson correlation to know the correlation value, to be certain of how well correlated these two values are. All right. So, but this is scatter plot generally. This is what you use scatter plot for, to assess the relationship between two numerical variables and also detect outliers. All right. So that is it for scatter plots. Let's quickly look at the other one that we have here. So you can do the same thing you can do for other chart plot that we've looked at. You can also do for scatter plot. You can actually change the marker, change the color, change the transparency. So this transparency is denoted as alpha in Matplotlib. So wherever you see alpha, it means transparency. So let's just illustrate that. If I come here and say alpha equals to 0.5, you see that these markers, they are actually a little bit transparent. They are not as bold as it was before, right? So you can see how the alpha parameter can change the transparency of this our data points here. All right. We can also change the color, and we can also change we can change the color. We can also change the markers. We are also the same thing we've been doing before. Let me see if I want to change the color to green, and change the marker to asterisk. So you see that we have this particular style here. So this is basically how you perform scatter plots, right? Just play around with it, change the x-axis label, the y-axis label, change the title, and a whole lot of other things. So when we start working with data set, you will be able to see how we would even introduce different levels to our scatter plot by introducing a different category as well, right? So you see in scatter plot like this, some particular data point will be green, while some particular data point will be red. So probably you are like segmenting your scatter plot into, let's say, male and female, right? So there's a higher level, an additional level you can add to this particular scatter plot. So you can make it like you can make it like that. So let me see if I can actually do that. But the problem is the length of this. The length of this. I don't know. Let's see. Let me just not just waste time with all of this customization, but because we still have some other plots to look at. So let's see, we have pie chart. So pie chart is pretty straightforward. We have is for categorical variables as well. The same thing we can do with bar chart. We can do it with pie chart, but with lesser number of categories. So let's quickly do that for pie charts. I'm just going to copy this because of time. We should be rounding up like very soon. So for pie chart, creating a pie chart. So we have your categories here and you have your values. So for pie chart, you have to put your values and your categories. So your categories should be your label. So in pie chart, it's not like the conventional way, right? They're actually X and Y axis, but it is interpreted differently. So you have what we call auto percentage. So this auto percentage, let's take a look at what exactly it means. So auto percentage, basically, it's a string of function used to label the wedges with a numeric value. So if you have your pie and you want to label each of the pie with a percentage value, you are going to use this formatting method. So just make sure you know exactly this string that we have here. So you can just put it here to give your pie, the different segments, a numeric value. So if I run this, I'm going to see we would have something like this. If I remove this auto percentage here, you see that my pie won't have anything inside, right? It won't have any, it will not be able to determine the different percentages for the different segments. So that is why we have this auto PCT here with this particular formatting, percent 1.1f percent in a string. That is just it, all right? So this 13 angle can be customized as well. You can change it to whatever you want. You can change it to 40, all right? And this label categories, if you don't put it, it's not going to label your categories for you. So this pie chart is pretty straightforward. You can actually use other parameters like explode. Let's say you want to explode your pie. Let's say I should be numerical values, right? Let's say explode. You can even put your shadow there. You can put a lot of things, right? So it's just left for you to like play with it and see how you can like just use these different customization options. All right, so let's see. So let's say this explode. I don't have time to start figuring out how to get the value. But shadow is true. By default, it is false. But if you make it true, you're going to have a shadow. You can see the shadow here and a lot of other things. So the start angle has been changed. So to move the segments of your pie and all of that. So that's it for pie charts. So since you already have the basics from other chart type, you can just like look for how, just look at the documentation and figure out how to create other chart type. So the ones we have remaining, we have histograms, and we have heat map. So this heat map, we are going to be using it when we start machine learning, basically. But let me just quickly show you histogram. So let's say we have a distribution. So histogram is for just one variable, right? So you have a data distribution. Let me make it X rather, because we have more values there. So you can see our histogram here. The reason why we have this is because we don't have plenty of values, right? Normally, histogram would work with a data set that has a lot of observations. So it should be, let me change this bin to, let's say, 50. So you can see it has a lot of spaces because of we don't have a lot of values to fill in these spaces. That's why we have space. But by default, we're not supposed to have spaces in our histograms. Let me put 20 here. So you can see how the spaces are closing because we are reducing the number of bins. So there's a very important argument in histogram, which is bin. So the bins argument corresponds to the number of this rectangular bar. So this rectangular bar in histogram is called bin, a bin. So this bin argument is basically set to determine how many number of bins you will have in your histogram. So if you put 20 here, you would have 20. If you put 5 here, you have 5. If you put 100, you have 100. So if you have a lot of data, so it will be necessary for you to increase the number of bins so you can actually appreciate the distribution of your data. All right. There are a lot of other things that we would see or that we can do in our histogram. This edge color, if you remove it, it doesn't give us anything, right? So it will just be plain like this, all right? But the edge color is going to make it's going to segment it so we can actually identify the discrete bins that we have. If you check the ist function, you see we have a lot of things here. We have color, we have label, we have this type. So the customization in Matplotlib is a lot, all right? So I would actually encourage you to go through all of these, play with your data, play with different data, and see how you can come up with different visualization. All right. So at the end of your viz, if you finish like creating your viz, you formatted everything, you can actually save it. All right. You can actually save your viz. Yeah. So you save your viz using. Okay, we have heat map here. For heat map, as I said before, this is the last one that we have. We're going to look at it when we start looking at machine learning, and I don't want us to just waste much time on it. When we look at confusion matrix specifically, we are going to see how heat map is being used. All right. So that's basically it for today's class. Let me quickly just give me a second. Okay, so as I said, we would have we can actually save our charts after we've created them, and the way we can save our charts is by using a function from the plot module, which is called plt.savefig. So once you do this, you have to bring it to the particular fig that you've created. Let's say I want to save this my bar charts now. You can come here and say you can come here and say plt.savefig, paste it here, and then the argument to take is the name of the fig. So I can say bar.png. All right, so this is the extension. You just type it out with the name and the extension, and I will like run it. So automatically it's going to save like in my directory. So if I come to my directory here, I should be able to see my bar. So you can see the bar.png. I don't know if Jupyter Notebook can open it, right? But if you open that particular you have to see your bar chart, right? And you can send it to anybody. You can just use it to do whatever it is you want to do. So you can see here that we have our saved page. So Jupyter Notebook, it doesn't really open it well. So you can open it with your other photo image open editor and all of that. So that is it for Matplotlib, right? I think this introduction is enough for you to have an idea on how to use Matplotlib, right? So if you were able to catch up, the recording will be made available for you to go through and assimilate better. So we're going to be wrapping it up now, and tomorrow we will now finalize with pandas and Matplotlib together and wrap up with the part 2 of this program, which is data analysis and visualization. Then we'll move on to the next phase from next week, which is going to be on machine learning. All right, so we are making a lot of progress, right? And I'm really proud of how far we've come. So please, we are done with today's class. If you have any question, you can indicate by raising your hand, and I'm going to be taking these questions and then call it a day. So if you have any question, please let me know. All right, Olayemi. All right, ask a question. You're on mute. You can ask your question, Olayemi. You raise your hand. Okay. All right. So I'm not seeing any other hand raised. So I feel either we are still trying to assimilate it, or we don't have any question at the moment. So if anyone pops up later on, you can just like ask it on the group chat, and I'll do my best to answer them. All right. So okay, so one hand is up. Paul Alabi Paul. Paul, ask your question, please. Hello, Paul. Can you hear me? You're on mute now, so ask your question. Unmute yourself and ask your question. All right, so I think with that, we're just going to call this a day. If you have any question, please let us know. And as usual, please drop whatever it is you've been able to learn from today's class in the live class. I believe we've learned a lot regarding visualization. So don't fail to share it with the rest of your colleagues and with me as well, so I can go through them and react and comment on the ones that I'll need to comment on. So yeah, thank you very much for your time. See you tomorrow by 5 p.m. And yeah, cheers and enjoy the rest of your day.